Hi everyone, my name is Tyler Slaton. I'm a founding engineer at CopilotKit, and I'm currently all in with the company on agent user interactivity. So what is CopilotKit before we get started? Well, CopilotKit is the framework for building AI copilots, which are user-facing agentic applications. We're open source. We have 30,000 GitHub stars, 200,000 weekly installs, and we're growing week over week. We work with Fortune 100s, unicorns, startups, and really everyone in between. And we're used by 10% of the Fortune 500s. Finally, we're the company behind the AGUI protocol, which is one of the fastest growing TypeScript AI projects. So quick agenda. Today, we're going to be going through really 5 points. We've already done the introduction, so actually we're going to go through 4. The state of Agentic UI, AGUI, Agentic UI patterns, and then what we see at CopilotKit as on the horizon. So to get started, let's take a look at the current state of Agentic UI. At CopilotKit, we're really fortunate to be able to talk with many people that are building agentic applications, both in enterprises, in the open source, and kind of anywhere in between. As we interact with these people, we've noticed that there's 2 core use cases that we've seen that people are trying to build in today's AI ecosystem. And these are really SaaS copilots, where you're trying to take some agentic workflow and funnel it into an existing SaaS application to make that SaaS application easier to interact with. And then there are productivity copilots, where you want to work alongside a user to get some core work done. So let's take a look at both. So a great example of a SaaS copilot is the Breeze Assistant inside of the HubSpot CRM. You can ask it questions and queries about your data, like, for example, what were my sales last month? And it'll give you an intelligent response based off the data that it has grounded within. A great example of a productivity copilot is a little bit different, though. Something like Cursor, where you and your agent are interacting together to get some work done. But there's kind of one challenge that we've seen as we've been building with this community. And it's that agentic applications are really complex. But why is this? Well, agents break the request-response paradigm that we've established over the past 30 years of the internet. In standard non-agentic applications, you get a request, you submit a request, and then you get a response, and that's it. With agentic software, there are long-running processes that require streaming as a result to get good UX. You can't build an agentic application if you don't focus on streaming. They also can take structured and unstructured input and outputs, think things like text, but also different modalities like voice, tool calls, images, and even state updates, which we'll get to. They require composition. So as you go through a complex process, maybe through a supervisor pattern, they require handoffs to different sub-agents, and your user very often wants to be aware of what's actually happening in that situation. And as we'll get into, you can also do non-deterministic UI patterns that make it really hard with existing response request or request-response paradigms to get consistent results. So what can we do? What did we do at CopilotKit to solve this problem? That's where we created the AGUI protocol, which is the agent user interaction protocol for connecting agentic backends and frontends. So let's take a step back. And let's look at the current protocol landscape, because there's a few protocols as we see it, but there's a lot of protocols out there. In the agentic ecosystem, the 3, as we see it, main ones are MCP, A2A, and AGUI. As you can see here, these are all flowing into and out of the agent, so how are they complementary to each other? Well, first of all, we see MCP as the model context protocol, which is context like tools, context like resources, and context like prompts. Those go into your LLM and can augment its generation. A2A is for 2 agents communicating together, or multiple within a mesh. And it has different concerns than what AGUI does, which is AGUI is really the agent user interaction protocol for clients and servers. So let's talk a little bit about that architecture. First, AGUI is an event-based protocol, again, for connecting agentic backends and agentic frontends. But what is CopilotKit and how does it fit into this? Well, CopilotKit is a React consumer a React UI consumer of AGUI streams. So any AGUI server that is emitting AGUI events can be consumed by CopilotKit. And you can build UIs on top of that, creating agent-user interoperability where your agents can be interoperable with your UIs. So we've had a really great adoption of this. First came the agent frameworks when we released this about 6 months ago. We had a great partnership with LangChain and Crew AI, and we also launched AGUI when we open sourced that protocol with Mostra, AG2, Agno, and a few others. A few weeks ago, we also released our collaboration with Google, where the Google team collaborated and created an AGUI integration alongside of us. And just this week, on Wednesday, we also released collaboratively with Microsoft the .NET agent framework and Python agent framework integration, where their team actually contributed to their framework AGUI integrations, which they're going to be extending into things like different clients in the .NET ecosystem. And it had a really powerful reception over the last 6 months. We went from 0 installs of AGUI to 151,000 each week. Our star counts are now at 10,000 as well on AGUI. And across the ecosystem, it really struck a nerve and really lit a fire to continue agent-user interactivity. Let's talk a little bit about how it works. So AGUI is a set of 16 standard events that are optimized for agent and user communication. They're transportless in the sense that we can communicate over HTTP, WebSockets, WebRTC, and any form of transport. And it has a client-server architecture where the clients are things like React and the servers are your agents. If we take a look at this architecture diagram, which may be a little bit small, so I'll just narrate over this, we can see we have AGUI middlewares and we have AGUI servers. What's the difference? So an AGUI middleware is a server that already has an existing streaming protocol that is converted into, at runtime, AGUI events. So that when you consume input and output, that is a standardized interaction. AGUI servers, on the other hand, are natively emitting AGUI events and natively receiving AGUI events. If we take a look, it might be a little bit small, but there's a couple of things I really want to point out on the example AGUI stream on the right-hand side there. You'll see that there's a run started that happens with a thread ID and a run ID. Thread ID being thread ID capturing the entirety of a conversation, whereas a run is one interaction that triggered an agent. We have a text message start, but you see there's no content there. It's actually just a role of assistance. The content comes through deltas, and this is what AGUI is great at, which is efficient streaming of structured data, like messages, like state, and we'll talk about these things. At the end there, you can also see, just to put a cap on it, a run finished that says that this execution has completed, which lets us know we are ready for the next input. So with that in mind, with AGUI in the back of our mind, with CopilotKit in the back of our mind, I want to talk about design patterns that we have been iterating on and implementing at CopilotKit with both our ecosystem as well as our customers. So as we see it, generative UI is huge. It's a huge pattern, we're going to talk about it. And there are 3 main kinds of generative UI. Static, open, declarative. Okay, that's great, but let's take a step back. What even is generative UI? This is UI, some component, some visualization that your agent is transmitting to your user. And this can be done in 3, as we see it, ways. So let's talk about static UI. You probably already interact with static UI pretty frequently today. This is where you are mapping generated data to existing components in your code base. It allows for deep control over the UI generated by your agents, and it lets tool calls and agent state be typical targets for user components, user-facing components. In this example, this is a pretty minimal one that's pretty common, which is just a weather component where the agent is returning a static result of 38 degrees Fahrenheit in New York City. Let's take a look at some of the code, though. On the left-hand side, you can see there is a dummy agent framework that I built, written in Python. And on the right-hand side is some CopilotKit code. You might see this new V2. This V2 is actually our new interfaces. So if you've used CopilotKit before, we are releasing a new set of interfaces that will make it easier for you to build AGUI interactions inside of your applications. Let's take a look at a couple of things here. On the left-hand side here, I've defined getWeather, which is a tool. I bind that into my agent as a tool, and I'm using the new GPT-5.1 model. Then I call agent.agui.serve. This is a pretty common pattern with all of our integrations, where they create a server for AGUI to be emitted within their framework. On the right-hand side, I have two things that I import. One is Copilot Chats, another is use render tool. And this is that mapping of static data generated by the LLM. Oh, okay, just went to sleep. Hope you guys aren't asleep. Okay, so this is that static mapping of UI from the back end to, or of data from the back end to UI on the front end. So that's what the use render tool is doing. It's just registering a component called weather card for the argument of location and the result of temperature. And we can map that into our Copilot chat component. The end result is something that looks like this, where I can have a chat with my agents. I can ask it, what's the weather in New York City? It's going to return a card with that result. And on the right-hand side here, if you've ever used CopilotKit before, this is actually our new design language that you'll be getting out of the box with our V2 interfaces. You can also do this with another interface that we're shipping with CopilotKit V2, which is the use agent hook. So the use agent hook is built on the paradigm of AGUI, where you want to just consume that raw stream and interact with that agent. So AGUI ships with a variety of clients, if you saw earlier, like React, but those are also language-based. So what's actually happening is React is consuming the TypeScript client. That TypeScript client has an abstraction for running your agent, providing it context, providing it messages, and it also has a middleware concept where you can have full control over the agentic request lifecycle. On the left-hand side here, what this use agent doing is actually quite clever, where it's creating a clone, a read-only clone on your front end of that agent with the same exact interface that you would use with that TypeScript agent, the same exact interface that we use to create CopilotKit, but it lets you do it in a headless way. And so now you can programmatically execute your agents, you can programmatically add messages, you can do time travel, you can reload messages, you can also do generative UI, which you can see here. We have a message.content, which is the text, and a message.ui, which is the component to render. So there are some pros and cons to this. First, the good. It's really simple. It's really simple to understand as well. And it gives you really full control over your UI, which will keep your designers really happy. And it's great for the common paths, the common treaded paths within your application that your users commonly go, because you have great granular control over what that UI looks like and how it is structured. Some cons. Really high coupling between the back end and the front end. Your agent team needs to be aware of your UI team, and your UI team needs to be aware of your agent team, because these two need to communicate the tools and the UI that can be rendered within. Otherwise, you'll get very generic UIs for your tool renders. Similarly, your code base grows linearly with the different use cases you'll have. So let's talk about some other ones. Open-ended. What does open-ended mean? So open-ended is basically where the agent returns some fully open-ended content. This can be an iframe, or this can be raw HTML that we actually set within our chat. And very often when we talk with people, this is what they're thinking about when they think of generative UI. So why isn't it prevalent today? Well, it's starting to be. So this is where things like MCP UI and the Chat GPT Apps SDK come in, where it is returning to you a link to an iframe that you can embed within your chat, and through the iframe primitives within the browser, you can actually interact within and out of that iframe. So you can get some interaction here where you have some UI. And this is generated either by a server or fully by an agent. So let's talk about the pros. Really low coupling between the front end and the back end. You can literally render anything from your agents inside of your UI. This is great. So now we can have our agent teams go and build UI for our front end. So let's talk about a bit of the cons. The UI may vary unpredictably, in the sense that your agent team may go and build some UI that it thinks looks great and fits great into the UI front ends, but its common use cases may suffer because there's no longer that coupling, so there's no longer that communication. It's pretty difficult to style. It's really hard to style the internals of an iframe. When it's HTML, it's also similarly hard because it's structured data that you have no awareness of what's actually taking place. It has some security and performance concerns. The performance mainly that you're rendering a bunch of DOM objects within a chat. And it's typically a web-first experience. So when you get into native environments where you don't have access to something like a DOM, it becomes really hard. So moving on from that, this is the last one, and this is one of the more emerging ones, which is declarative UI. And this is a semi-open spec for designing constrained UIs that the agent could generate driven by a declarative spec. It's somewhere in between static and open-ended generative UI, and it's typically described by cards and widgets with recurrent elements. Let's take a look at an example. So in this example, this is open JSON UI. This is a spec that is emerging at the moment, where you have a card that the agent generated, but it doesn't have any specifications of what that card looks like, right? We also have an image with an airline logo and a size, some text value, and then it closes out that markup. And it can result in something that looks like the bottom right. What's actually happening here, though, is that in your UI, you are mapping this generation from the agent to a component library. Think about ShadCM, or any component library you may know, like Radix, for example. These are component libraries that have really structured ways of rendering UI. And now, with this approach, your agent has the capacity to go and generate any combination of those elements together. Okay, so this is great. So it lowers the coupling again between the front and the back end. It can accommodate a lot of common use cases, and it gives us really extensible rendering and ways to render and ways to swap out our rendering within our UI. But it can't really accommodate fully custom UI needs. It's really constrained by the spec. So whatever this is in the spec is all that your agent can generate. And sometimes it can get into some weird situations where it's trying to get something, but it doesn't have the exact component that it needs. So it does some weird UIs to get around that. So your UI may vary unpredictably. So some of your common use cases may suffer. So you have to do a lot of context and prompt engineering around that to make sure that it doesn't try to smash its head into a wall. So what does AGUI support? We just talked about 3 of these. Well, AGUI's whole approach is to embrace, extend, and innovate on. So we've already embraced generative UI for static generative UI fully. You can go and do that with CopilotKit right now. We also have great support for open-ended UI, where you're able to, through projects like MCP UI, render that within the Copilot chat. And as the declarative UIs come through and the declarative specs come through, we will also fully support that as well. Okay, let's move on. Take a quick step back. We're still in design pattern land. We just talked about generative UI. Let's talk about state. So agents are these stateful pieces of software, right? LLMs are stateless, famously. Agents are typically stateful. They're a stateful abstraction on top of LLMs to allow us to do a lot of interesting things like memory, like message history, like persistence. Can be messages that are in that state, but it could also just be structured data, right? Think about a chart. Chart is structured data. We could also put that into our state. We could put user preferences into our state. Finally, it can be generated, but it doesn't necessarily have to be. This can be statically programmed in your UI if you're familiar with any agentic state. This is very easy to do. It's just code at the end of the day. Let's take a look at this within the confines of CopilotKit's new V2 interfaces. So here on the left-hand side, we have that made-up agent framework I have. I've created the same 5.1 model. I bound in some tools that I haven't defined for the sake of brevity. But I have this new thing here, which is this state schema. That state schema has a name string. This is going to be the user's name that I want to store as I go through and execute some interaction in the UI. Again, I call agent.agui serve, and then we get routed to the front end. On the front end, again, I call that agents, and now in my agent, I now have state coming through. I can call agent.state.name, and I can read that state on the front end. But this is bidirectional, where I can also, on the front end, send an update to the agent to update that state. In this case, I've updated my state schema to something like a counter. And as I click the button on the right-hand side, that counter will go up, and the agent will be aware of that state. And you can imagine and start to visualize how this might scale. Like, for example, into a Canvas application. Who here has used V0 before? Lovable, anything like that? Keep your hands up if you used anything that's kind of like those things. Great. So that's what's really happening behind the scenes is you're having a stateful interaction with that agent, that piece of software, right? What's happening there? Well, there's a couple of things. On the left-hand side, I have a document, right? Let's imagine something like I'm writing an email. I also added a new tool in here called Generate Documents that will be able to, let's imagine, for the sake of brevity, be able to update that state. Now, on the UI side of this, I can have the agent render, I can have a rendered version of that agent's document, and I can also have the user edit that document. So I have a collaborative experience, kind of like Cursor, where the agent's writing something, and then I can edit it. And then I can edit it, and then ask the agent to update it. So what does this look like in actual execution? Let's get into a quick demo. So this is an application I wrote for a workshop that we do in the San Francisco Bay Area with the Pydantic AI team. So behind the scenes here, we're using the Pydantic AI integration, and we are just going to be talking with this. I've had some internet troubles today, so let me just make sure that this is live. Looks great. Cool, so I said hi to this agent, and this is a simple to-do application, right? It's minimal for the sake of a workshop, so we're just gonna talk through pieces of it. The first thing I wanna do is ask it to add a to-do to my list to build a website. Great, done, it's there. Now, what if I wanna move that to completed? I can ask it, hey, what's the state of my current to-dos for the website? It's going to, sorry, it's supposed to get it. It didn't, can you get your state? There it goes, cool. And now it learned, hey, actually, I lied, it is done. So what happened there was I moved the state over, and then I asked the agent, hey, can you get your to-dos again because you lied to me? And then now the agent is aware of that to-do. I can also ask it to change the theme. This is a pretty novel one, but I'll talk about what's cool about this. So when I set the theme to purple, this is not a normal tool call. What's actually happening here is this is a front-end tool, where on the front end, we've defined a tool schema, we've passed that to our agents, and we've asked our agent, hey, when relevant, please execute this action. But it doesn't get executed on the back end. The execution actually takes place on the front end, where we have complete access to the DOM. So I actually called some React state right here to edit that for my entire application, where you see this nice purple transpire across the entire application. I can also ask it to move the first to-do into in progress. I'm just gonna start to interact with the agent in some more novel ways. I implemented this action called fully send it, which is basically just gonna take all of my to-dos, mark them as done. And this is a human-in-the-loop interaction. I really wanna zoom in on this because we'll talk about it a bit more in a second, where I am asking the agent to do something, the agent goes and does it, and then asks me for permission before it does it. So in this case, I hard programmed, hey, when you call this tool, fully send, always ask me before you do it. So there it goes, awesome. And it's aware of that state, so it's gonna go ground itself in that state again. Great, fantastic. So that's a quick example of what you can envision with a Canvas application. Very minimal, but you can scale this up to really complex workflows like the V0s, like the lovables, like the cursors of the world. So what's on the horizon as we see it at CopilotKit? Well, first, we believe that 2026 is going to be the year of voice agents. Why? Because voice is extremely intuitive, and conversation can continue as work happens within your UI. If you remember earlier, you might have heard me say that AGUI is a transportless protocol. What's great about this is that we can also support things like WebRTC, where now we can provide that into the entire ecosystem of AGUI. And we're all in on it. Next up is agent steering. The more autonomous the agents become, the more important the mid-run steering becomes. This is because as autonomous agents go and do work, they can very often get off task or very slightly make adjustments through their task that ultimately lead to the wrong answer. And agent steering is the answer for this. Finally, and this is where we're going all in from a product perspective, is self-improving agents, where we have all of these signals of human edits, we have all of these signals of approvals or denials, we have all of these signals of what your agent's doing and how your user receives that. You're collaborating with your user, you're getting their edits, and you're getting that feedback as signal, and then you can use that to improve your agent over time in what we're calling automatic RLHF, or reinforcement learning on human feedback. So what are some of the conclusions that we can drive? First, agents are becoming real. 2025 was very much the year that agents became real. In 2026, we're going to be refining them. Agents change how we think about UX and how we think about UI. Generative UI is an essential pattern in this, where we can provide user context that's no longer text-based. And finally, voice modality will grow, and it's going to grow fast in 2026. Finally, Auto RLHF will provide agents with learning at scale in your application, where human intelligence can be used to train your agents. So I really appreciate it, everyone. That was my time. I've been Tyler Slaton, and yeah, thank you.
That was a really fascinating talk. Okay, we will take one, maybe two questions, but we are moving into happy hour after that, so the conversation can continue.
Thanks for the presentation. Can you bring your own design system?
Can I break my own design system?
Yes.
What do you mean by that?
So let's say if we already have a design system where we have opinions about how the buttons
yeah.
and stuff like that.
In CopilotKit, absolutely. And with AGUI, absolutely, absolutely. Because it's all just raw data that you can map directly into that UI.
One more question.
Could you please elaborate some on why you think voice modality is going to become the big thing in 2026? Like, are you imagining like product development is going to become a collaborative thing? It could be happening like within a Google Meet, for example. Like, is that going to be the input to the next lovable? Or how do you see that?
I see these agent interactions. We see at CopilotKit these agent interactions as taking place not only through text, but also real time through voice. So all the generative UI I just mentioned to you can be surfaced in real time by an agent. This is already supported with the top models like Gemini Real-Time and OpenAI, where they also have support for tool calls, which supports everything we just showed, where you can do generative UI on these things, and you can collaboratively have a conversation with your agent. You can say, hey, can you get me a booking at this restaurant that I want to go to? It can then render a component to you and have a conversation, but as that's happening, you're not waiting on the agent to respond some text. It can have oversight over what's taking place, and you have a continued conversation as that long-running process is taking place. So as we see it, voice is really a modality by which you can communicate with agents. Maybe that's in a Google Meet, but I really feel, and we really feel, that voice is going to be a really convenient way for users to start to adopt and interact with these generative platforms.